Howdy there, Internet students. This is Mr. Hermanson again. This is day 2 of 7.3D. We're trying to learn how to write systems of equations so that we have some math that we could solve and find the answer. I was thinking that this actually really makes you a powerful problem solver when you learn to do this. So today we're going to be tackling a little bit tougher problems, so you're really going to have to be paying attention here. So let's move on to the second page here, mixture problems. So this is something you're going to be doing a lot in your chemistry classes. And yes, you're going to be using lots of algebra to do that. Okay, so here's our problem. We have one antifreeze solution that is 20% alcohol. We have another solution that is 12% alcohol. And we're going to mix them together. So a little bit of each, so that we should end up with 15 liters of antifreeze that is 18% alcohol in the end. Now, some of that can be kind of confusing, so let's make it a little bit simpler. First of all, let's just add up our solution. Let's say that X represents how much of the 20% we're going to use, and Y represents how much of the 12% we're going to use. Then if I add the X plus Y together, that will equal 15. That one's pretty simple. Now in our second one, and here's the important part, we're going to measure the alcohol content. Now in the end, we want 18% of the solution to be alcohol. So 18%. Now I'm going to go back to our percent days. 18% of our 15, so this is the proportion that would look like, is how much? So we got to first figure that out. And that equals 2.7. So 2.7 out of our 15 liters will be alcohol in that mixture. So I'm going to put that right here is 2.7. Now the way we get that alcohol content is in our X solution, there's 20% alcohol. So that expression looks like this, 20% of X. So that right there is the alcohol in the 20% solution. And then likewise in the 12% solution, and Y is how much of that 12%. So this is the alcohol that I'm adding up, the alcohol in the 20% solution plus the alcohol in the 12% solution. All right, now whenever my equations are written in this form, which is called the standard form, where both X and Y are on one side, I like to use elimination. Now, what I'm thinking is if I multiply everything on the top row by, say, negative 0.20, multiply everything on the top by that, I'm going to end up with an equation that has negative 0.20 right here. And then I'm going to add them together, and that'll get rid of the X, and that'll tell me the Y part. Okay, so I have to multiply negative 0.20 times Y. And I also have to take 20% of 15, which is 3. Now I'm just going to add those together, and I'll put that up here. When I add these two together, I get negative 0.08 Y. And when I add these together, oops, I think one of those should have been a negative, right? This should be a negative 3. Yeah, so I get negative 0.3. And now all I have to do is divide negative 0.3 by negative 0.08. And that gives me 3.75. So 3.75 liters of my solution is the Y solution, the 12%. So this is the 12%. How much of the 12%? Now we're going to have 15 total, so I'm just going to quickly subtract my 3.75 from 15, and that gives me 11.25. That's the 20% solution. So I need 11.25 liters of 20% solution and 3.75 liters of 12% solution. All right. So go ahead, you're going to do this next problem. Remember that the decimal for 1% is 0.01. The decimal for 3.5% is 0.035 when you try to do this. All right, give it a shot, and I'll show you my work soon. All right, I got that you need 40 gallons of the 3.5%. And you need the other 60 gallons to be the 1%. All right, now what I did is I multiplied everything on the top row by 0.01, negative 0.01, and then I added them together to get, so I use elimination there. All right, the next problem we're going to do is solving a wind or current problem. Okay, now these little equations actually turn out pretty simple. So so you just got to imagine the problem. So you're rowing upstream. That means you're against the current. So, and when you're against the current, let's say that if there was no current, you would go 10 miles per hour. And let's say you're rowing against a 3 mile per hour current. Well, you just subtract those two to get your rowing speed, your actual rowing speed. So 10 minus 3 is 7. So you're actually rowing at 7 miles per hour when you're going against a 3 mile per hour current. Likewise, if you're with the current, you would add that 3. So that's what my equations look like. So let's let x be your whatever your normal speed would be. So your still water speed. So, and y will be my current speed. Then x plus y equals my speed going downstream, which is 5. And then if I do x minus y, that would be against the current, and that is my speed against the current. Now, obviously, elimination is going to be awesome here because you have a plus y and a minus y, so I can just add the two together, and I get 2x equals 7. Dividing by 2 gives me x equals 3.5. And so that's my speed that I'm rowing. And then if I do, since they add up to 5, my y would be 1.5, which is the speed of the current. So these are my speeds. This is my rowing speed, and this is my current speed. All right, so why don't you try one of those? This one has to do with airplanes, but it's the same idea. Give it a shot, and I'll write down my equations and see if we agree. So here's what I got on that one. All right, we're going to do one more problem together, and this is going to come from that extra practice sheet. So you may need to pause here and go find that extra practice sheet. That's this one here. And there's a problem of basketball I'd like to do here. It's this one, number 5. On December 13th versus the Washington Wizards, Shaq scored a season high in points, 40. Got 40 that day. His 40 points were scored all on free throws and 2-point baskets. All right, so right away, let's let x be how many free throws and y equal how many 2-pointers. So we're just going to say x plus y equals the total number of shots that he took, which is 25, or that he made. And then we're going to add up the points. That should equal 40. So the free throws, which are 1 point each, so 1x plus 2y is equal to 40. Now, since these are both exactly the same, elimination would really work fast here. And I'm actually just going to subtract the top equation from the bottom one. X minus x is 0. 2y minus y is 1y. And 40 minus 25 is 15. That worked out really fast. So 15 is the number of 2-pointers. Let's just make sure that works. 15 times 2 is 30 points there. And if we do 25 minus 15, that means he had 10 free throws. They're each worth 1 point. So 10 points on free throws. And if we add that up, that equals 40. So that works. All right. So I hope you found this helpful. And I'm going to give you some time to practice now. This Kobe Bryant problem will be part of your assignment. Good luck with that.